We are moving ahead to the next theoretical module of stationary waves, and this theoretical module is termed as the concept of harmonics and overtones. Now students, remember, the distinguish between harmonics and overtone is one of the most favorite question in the board examination. This question has a weightage of 2 to 3 marks, and students, mind you, it is one of a very important questions. So to study about harmonics and overtone, let us start with the concept of harmonics. To define harmonics, the word harmonic is used to represent fundamental frequency, that is the basic frequency, and all its integral multiples. So, if I generalize the formula of harmonics, it will be something like this. Fundamental frequency multiplied by P is equal to harmonics, where P can have the value starting from 1, 2, 3 up till N. So if I keep 1 over there, so it will be fundamental frequency multiplied by 1, so it will be the first harmonic. If I keep 2 over there, so it will be second harmonic, and so on. So when I have to write the general approach or the general formula, the first harmonic will be 1 times into N. That is 1 times the fundamental frequency, hence it is called as the first harmonic. So that is the reason why harmonic was defined as the fundamental frequency and all its integral multiples. In the second harmonic, we know it is twice N, that is 2 multiplied by the fundamental frequency will give me the second harmonic. And subsequently, we will have the third harmonic as 3 times N. If I have to show you the general approach or the diagrammatic approach to this concept, then we can see the string. When I plug the string at the center, I get the formation of one loop. And this one loop is actually a stationary wave. But what is a frequency? Can I say this frequency is the first frequency, and hence it is the fundamental mode. Since it is fundamental mode, there is only formation of one loop, and it is only called as the first harmonic. But in the second case, as we all know, we had 2 loops, and the frequency was 2n. So can I say this is not the fundamental mode, this is the second mode of vibration of a string. And second mode has the formation of 2 loops, which is also called as the second harmonic. In the third case, we have the formation of 3 loops, and this is 3n, and it is called as the third mode, which has 3 loops formation, and it is also called as the third harmonic. Moving ahead to the concept of overtones. The integral multiples of fundamental frequency, excluding, means I'm not going to consider the fundamental frequency. I'm not at all concerned with the fundamental frequency, and I am only concerned with the integral multiples which are actually present. These integral multiples are called as overtones. So in overtones, I'm not considering fundamental frequency, but all the other frequencies except for the fundamental which are actually present are called as overtones. So first overtone will be the first higher frequency which is greater than the fundamental frequency. The second overtone will be the next higher frequency which is greater than the fundamental frequency. So can I say I now know what is the concept or the meaning of overtone? So let us now understand overtone with the help of diagram. In this fundamental mode, I know it is the fundamental frequency or basic frequency or the first harmonic. So can I say all other frequency apart from the first harmonic are overtone? So will this be an overtone? No, this will not be an overtone. After understanding this, we move ahead to the second case in which there are 2 loops. I know this is second mode where there are 2 loops, and this will be the first overtone. Since it has frequency which is greater than the fundamental frequency, and this is the first case, that is why first overtone. In the second case, where I have 3n, that means the third mode where there are 3 loops which are formed, and this is the second higher frequency greater than the fundamental frequency, hence it is the second overtone. So on the basis of this, we move ahead to the distinguish between harmonics and overtones, which is very important. As we know, the very first point, the integral multiple of fundamental frequency, including the fundamental frequency, are called as harmonics. But the integral multiple of fundamental frequency, excluding the fundamental frequency which are actually present, are called as the overtones. Some harmonics may be present in certain cases, but always remember, overtones are always present. In the next case, fundamental frequency is having the first harmonic, or it is called as the first harmonic, but fundamental frequency will not be called as the overtone. Students, these 3 points are basic points. In this, the second point, you will understand more when we study the vibrations in the pipe. We move ahead to the next slide. In this case, I know for a tube closed at one end, the harmonics are N, 2N, 3N, 4N. For tube closed at one end, the overtones are 3N, 5N, 7N. Now in this case, you can see N is missing because overtones will not consider the fundamental frequency. And students, the concept of tube closed at one end, you're going to study in the later modules. Also, in harmonics, all the harmonics are not overtones. Like first harmonic can never be an overtone, but all the overtones will always be harmonic. So this is a very important point, students. Remember, second harmonic is always twice the fundamental frequency, but second overtone may be 3 times or 5 times the fundamental frequency that we are going to study in detail in the next coming modules. So students, with the help of this module, we studied the concept of harmonics and overtones. Thank you.